Hello there. In this lecture, we'll talk about the partial variation. When a variation is expressed as a sum of terms, then we refer to such variation as the partial variation. For instance, if we have P, if we say P is partly constant and partly varies, as, let us say, another quantity Q, then we can write it mathematically as P is partly constant and partly varies as Q. What is the meaning of all this, or what is the implication of this expression? Now, we would know that where A is a constant of variation, we would have to introduce a constant to K also. If we introduce a constant to K, because K is already a constant, all right? So let us say we introduce B as constant of variation 2, and B is multiplied by K. So this will be P equals KB plus AQ. Is that okay? The reason why we wrote KB as K is because when you multiply a constant by another constant, the result is going to give you a constant. Is that okay? So constant times constant is going to give you another constant. If you are still in doubt, let me clear your doubt a bit. Let us say the first constant is 2. So 2 multiplied by another constant, which is 2, is of course going to give you a constant, which is 4. But if we have a constant, let's say a constant 2 multiplying a variable Q, of course the result is not going to give you a constant. Is that okay? It's going to give you a variable in this form. Do you understand? It's going to give you a constant multiplied by a variable. So that is why we have chosen to write the mathematical expression for P is partly constant and partly varies as Q to be equal to P is equal to K plus AQ. Having said that, let us try to state a mathematical statement by considering the example here on the screen. From this example, we would learn a better way of stating the mathematical statement in real sense or in practical sense. Is that okay? Now the question is, the discharge or the water discharge of a water pump partly varies as the square of the distance and partly as the level pressure in the reservoir. When 302 liters of water is discharged, the level pressure is 8 MB while the distance is 10 meters. Okay? And when 1204 liters of water is discharged, the pressure is 4 MB and the distance is 20 meters. Find the quantity of water discharged when the distance is 50 meters with a pressure level of 32 MB. Let us analyze this question very well. Okay, the first one, 302 liters of water is discharged. The pressure level is 8 MB and the distance is 10 meters. So when the water discharge increased, okay, to 1204, what happened to the other quantities? Of course, the pressure level reduced. Is that okay? So the higher the discharge from the water pump, the lower the pressure, and the distance increased from 10 meters to 20 meters. So you've seen the way these variables or these quantities relate to one another, right? Before solving this, would have to pen down the relationship between all these quantities. Okay, so from the question, we were told, let the water discharge be represented as W, okay, and then let the distance be represented as D. And if we decide to represent the pressure level as L, okay, now what is the relationship between all this? From the question, we're told the water discharge varies as the square of the distance, and also the water level varies inversely as the length. And I told you why the water level varies inversely as the length. Okay, from the question, when the water discharged was 302 liters, the distance was 10 meters, while the pressure level was what? The pressure level was 8 MB. All right, when the water discharge increased, what happened to the pressure level? It decreased. Is that okay? So there is an inverse relationship between the pressure level and the water discharge. Is that okay? So that is why we have W to be inversely proportional to the length. So what is the pressure level, rather, not the length? So what is the mathematical expression or the mathematical equation for this problem? Of course, this is equal to W varies as partly as D squared plus 1 over L. And from what we discussed previously, we have to introduce the constants. Okay, we have to introduce the constants A and B, which are called the constants of variation. So if we do that, we would have, let us introduce A and B. So this will give us AD squared plus B over L as the equation or the relationship between them. Okay, now what is the next thing to do? We're told that when W was 302, D gave us 10, and L, the pressure level, was 8. So if we substitute the values into W equals AD squared plus B over L, we will have 302 is equal to AD squared. 10 times 10 is equal to 100. So we can say 100A then plus B over 8. We can call this equation 1. This is the first equation. Now let us consider the second analysis given. They said when the discharge became 1204, okay, so when water discharge equals 1204, the distance was what? 20 meters, and the length, the pressure level, was 4. Okay, so if we substitute these values into this equation over here, we would have 1204 is going to be equal to, that will give us 20 square times A. 20 square times A is going to give us 400A, right, plus B over 4. Okay, and we can call this is equation 2. If we decide to solve equation 1 and 2 simultaneously, we would have 302 is equal to 100A plus B over 8. This is equation 1. To solve these, we can either use elimination or the substitution method, but I prefer to use elimination method by eliminating one of the variables and then obtaining the value for the other one, then later on substituting back into the equation that we have earlier, or into one of the equations, probably equation 1 or equation 2. So to do that, let us multiply equation 2 by 1 and equation 1 by 4, so that this would be equal to the same thing, and then we will subtract equation 1 from equation 2. If you do that, we can say times 1, and this is times 4, right? If we solve further, we'll have 1204 is equal to 400a plus b over 4, and this will be equal to 1208, which is equal to 400a plus b over 2. If we decide to subtract, would have these to be equal to, we can decide to subtract 1 from 2 or 2 from 1. They are still the same thing. So if we subtract 1 from 2, would have minus 4 is going to be equal to minus b over 4. And how did we get that? Of course, this will cancel out. So b over 4 minus b over 2. If I look for the LCM, I have 4. This is b minus 2b. Okay? So b minus 2b is going to give me minus b. It's just like saying 1 minus 2. It's going to be minus b all over 4. And that was how we arrived at this as our answer. Okay? So if we multiply through or cancel out and decide to cross multiply, we would have that b is equal to 4 times 4, which is equal to 16. Therefore, the value of b is equal to 16. Since we have b to be equal to 16, we can substitute the value of b into any of the equations, be it equation 1 or equation 2, to obtain the value of a. Is that okay? Let us substitute the value of b into equation 1. So as to obtain the value of a, 1204 is equal to 400a plus b over 4. So 1204 is equal to 400a plus b is 16. So we have 16 over 4, which of course will give us 4. So if we subtract 4 from both sides, we would have 1204 minus 4 is equal to 400a plus 4 minus 4. Of course, this will cancel out. This will cancel out. And we will be left with 1200 equals 400a. Dividing through by 400 would have these to give us a is equal to 3. So since we have a equals 3 and b is equal to 16, we can decide to substitute this value into our initial equations. All right? If we do that, we remember w equals ad squared plus b over l. So w would also be equal to 3d squared plus 16 over l. But we were told, they said, we should find the quantity of water discharged when the distance is 50. So when d equals 50 and when the pressure level is 32 MB. So when d equals 50 and pressure level is 32, we have w to be equal to 3 times 50 squared, all right, plus 16 all over 32. Okay? And if we solve this further, we will have w will be equal to 3 times 50 would give us 3 times 2,500, which would be 7,500. All right? 7,500 plus 16 over 32 is going to give us 1 over 5 or 0.5. So we have 0.5. So if we do this, if we calculate further, we would have w will be equal to 7,500 plus 0.5, which will be equal to 7500.5 liters. All right, 7500.5 liters as our final answer. So the level of water discharged, when the distance is 50 meters and the pressure is 32 is equal to 7500 0.5 liters. And this is where we'll draw the curtain for today's class. And I'm sure by now you have a better understanding of partial variation. And if you have been following our series on variation, you should be able to understand everything about variation. And variation should be a done deal for you whenever you come across any of the problems in any examination. Okay, so stick to our work, stay with us, and watch all your worries in any of the courses fade away. Till we meet again, bye for now.